Hello there, 10D1. I hope you're having a restful half term. This is a little help for the equations that you'll be doing during the break. It is not one of the ones that you have got, but it is very much like it. It's another displacement reaction. We've got on the reactants side, we've got potassium fluoride, which is aqueous, it's in solution. Magnesium nitrate, also aqueous, aka in solution. And then the reactants over here, we've got potassium nitrate in solution, and we've got some solid magnesium fluoride. So the things we're going to need to do is we're going to need to write a molecular equation. First of all, that is an equation that is concerned about the molecules. So to do that, to get our chemical symbols, we're going to need to have a think about which elements are in which group. So for instance, we've got potassium first of all. Where's our potassium? Well, there it is. It's in group 1. So think about what kind of ion it makes. It makes a plus ion because it's only got one valence electron to get rid of before it gets that it gets that stable electron arrangement. Okay, secondly, fluorine. Let's have a look at where that is. Well, that's in group 7, one of the halogens. That will make a minus ion because it's going to get its stable electron arrangement in a compound by gaining an electron. One more electron than it has protons, thus making it a negative ion. Okay, so, well, we've got to think about when that's in a compound, we have to think about whether it balances or not. Okay, and straight away, I can see that we can make a neutral compound out of these two because we've got one plus and one minus, so that's fine. So when I'm writing my equation, first of all, for potassium fluoride, I can just write Kf, safe in the knowledge that this is balanced because one atom of potassium has a plus sign and one atom of fluorine has a minus, and so they balance out altogether. Perfect. Okay, let's have a look at magnesium nitrate. Which group is magnesium in? Well, it is in the second group. Therefore, it is going to form an ion of Mg2+. It's going to lose those 2 electrons. Nitrate, that is one of our polyatomic ions. So you'll need to look that up on your notes from earlier in the year or on the internet, and also I will put one into the attachments for the resources as well. But nitrate is a polyatomic ion, and you count it as almost as if it was its own element. It is NO3 and its charge is minus. Okay, so do these balance out right away in the same way that K and F do? Can I just put MgNO3? Well, no, I can't, can I? Because actually, if I did that, I wouldn't have enough negative to balance out the positive that was brought by the magnesium. So in fact, what I'm going to do is I'm going to have Mg, and then I need 2 of these. I need 2 of these molecules. I need 2 NO3s. And the way we put that in notation is we put an NO3 into brackets, and I'll say that I have 2 of them. I have 2 lots of NO3 for every 1 lot of magnesium. Okay, moving on, potassium nitrate. These are our products. We know what potassium is. Well, in fact, now with all of these, because they are displacement reactions, once you've got all these ions, you'll see that they appear again and again. Potassium, nitrate, magnesium, fluoride. So it will speed it up really. Let's have a look. Potassium nitrate. Well, that's going to be fine, isn't it? That balances because there's a plus and a minus. Very nice. And then for magnesium, we have got magnesium with fluoride. That's not going to balance, is it? So for every 1 magnesium that I have, I get 2 plus, and for every 1 fluorine, I have a minus. So to balance that out, I'm going to need to have another fluoride ion for every magnesium, so that this now has a 2 minus charge to balance out the 2 plus charge of magnesium. Let's not forget our symbols showing our states of matter: aqueous, 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 and solid. Now this will become important when we get to our ionic equations. So that's a good start, but It is not balanced yet. The compounds are fine in terms of the ratios of atoms to each other. 1 to 1, 1 to 2, 1 to 1, and 1 to 2. That's fine. Those are compounds that are stable unto themselves, but the equation itself is not balanced. So let's do our usual, where we go filling in how many of each we have on both sides. So we've got some Ks, we've got some Fs, we've got some Mgs, and we've got some NO3s. Take that as if it was its own element, okay? Even if nitrogen or oxygen appears on its own in this reaction, still take the polyatomic ones as their own, okay? So we've got 1 potassium on each side. We have got a fluorine on the left and 2 on the right. We have got a magnesium on the left and 1 on the right. We have got 2 NO3s over here, and we've got 1 over there. Now, remember that the places you can put coefficients is here, and that will have the effect of multiplying those molecules by however many numbers you put there. Okay, so let's have a little think. We need to sort out these fluorines, and we need to sort out these nitrates as well. So I'll maybe start with the fluorines. Why not? I need some more on this side. Where are my fluorines? They're over there. Let's see what putting a 2 in does. What effect does that do? Times 2 equals 2. Well, those are balanced now, but I've also had that effect on the potassium, haven't I? Because I've put a 2 in front of that compound, thus doubling everything in that compound. So I've got 2, and now suddenly I've got an imbalance over here. I've got a balance there, a balance there. Okay, so let's look to the right then. Let's fix this potassium. So I'll put 2 potassiums in, times it by 2, and then we get 2. These are now balanced, and I've also had an effect. Oh, that's fortunate, isn't it? On the nitrate there. So times that by 2 as well, and that equals 2. That is your balanced molecular equation. Okay, now we need to look at an ionic equation. So working on for the same stuff, we want to do the Ionic equation now. Ionic equation. Right, moving down, there we go. So what you want to do for the ionic equation is you want to take apart the individual compounds into their composite ions. So for instance, it's essentially you've done the work before because we found out our ions in the first instance, haven't we? So now you're just going to pop them in individually one by one. So we've got 2KF. So an ionic equation, it's going to be 2K, and don't forget the charge, and that's aqueous, plus 2F with a minus, and that's aqueous. It's a bit like a Z. 2F, aqueous, and then we've got the Mg, 2 plus, which is aqueous, and the 2NO3, which is aqueous as well. So 2NO3 minus, and that is aqueous as well. Okay, now I'm going to draw this under here just to make it look nicer. The reactant side, what we've got is 2K plus, which is aqueous, and we have got 2NO3 minus, which is aqueous, and then finally we have got, now wait for it, it's a solid we're looking for now, isn't it? Because remember that the magnesium fluoride is solid, and therefore it does not form an ion. So it looks exactly the same as the molecular formula, okay? So it's just MgF2 because it can't separate into its ions. So if you get a solid or a liquid or a gas, then you need to keep it like this, okay? So only aqueous compounds split into their ions, okay? Not solids, not liquids, not gas. Okay, so that is your what's called your ionic equation. And then the very last bit, all we have to do now is do your net ionic equation. And that's, remember, where we're just removing our spectator ions. Yep. So that means we're removing the ones that don't change at all. Let's have a little look at what they are. So if we do our net ionic equation, we are removing spectator ions. Those are ones unchanged. Okay, so let's have a little look. On the left side, 2K plus, 2K plus. Well, they're staying the same, so they're coming out of there. 2F minus, does that appear again? Nope. Mg2 plus, does that appear again? Nope. And 2NO3 minus, does that appear again? Yes, that does appear again. So I'm going to take out the ones that don't appear again, so that I'm only left with the ones that are part of the change in reaction, to give a demonstration of the net change, because the ones that are unchanged are not part of the net change. So the ones that do change, we've got fluorine in its aqueous ionic form, and we can add it to the magnesium in its aqueous ionic form. They react to give magnesium fluoride, solid magnesium fluoride, okay? And that is you. Those are the steps, okay? You've got to work on the molecular equation, where you can find how to write that by finding out what ions the elements make, and therefore how many atoms of each will appear in a compound to make that compound neutral. You'll then balance that equation. You'll break it down into its composite ions, remembering that only the aqueous compounds split into their ions, not solids, liquids, or gases. And finally, you'll take away the spectator ions to leave you with a nice net ionic equation. Okay? I really hope you do have a good break, folks, and I hope that was nice and clear. If not, shoot me a message, but I think you will be just grand. Okay, thanks very much. Goodbye.